as promised, or yeah, as promised. We'll start, this is actually L2. Sorry. We'll start an example here. Example problem. So I'm going to draw kind of a rigid static structure. So this is like the ground. So anytime I draw a surface and I draw kind of hatches like this, I'm saying this is a solid surface. This does not move. And let's say we put kind of an eye hook into this. What do I mean by that? Well, it's you've probably seen them before. It's like this hook. It's got like kind of a ring on it, and there's probably some threads that you can kind of screw this into. If this is a wooden board, for example, I could screw this down into it. Okay, now what I've got here is we're going to apply two forces to this hook. Maybe we've attached strings or something. We're going to apply one force F1 here has a magnitude of 100 newtons. And we're going to apply a second force up here. Second force is going to be applied F2, has a magnitude of 150 newtons. Now, as I mentioned, for me personally, when you're doing your homework, your textbook's going to give you maybe a paragraph or at least a sentence or two that goes along with this. You don't have to write that out. For me personally, now if you're taking it for somebody else and your instructor says, no, you have to write verbatim exactly what the textbook says, do those things, right? For me personally, again, the biggest thing is make sure you say, what are you looking for here, right? Find the resultant force on the hook. That's all this problem's asking for. So that's all you would have to write, for me personally. And it's really more for you when you're doing this homework. You need to be able to go back and look at these and study and say, well, what the heck was this problem trying to do? Now, there's additional information given to you in this problem. They've given you from horizontal that F1 is 15 degrees from horizontal, and F2 is 10 degrees from vertical. So, we want to find the resultant applied to this. Remember, they said, what are you looking for? We want another resultant. What is known? Well, we know these things. We've recorded that from our textbook, and that's now a diagram in our problem here. Okay, what laws or equations, rules, tools do you have that might be useful? Well, we've talked about vector operations, and if I wanted to bust out a ruler and a protractor, I could probably draw me a vector down here at roughly 100 millimeters long at 15 degrees, and then draw another vector on top of that, roughly 150 millimeters long, 10 degrees from vertical, and graphically add them together, measure the resultant, measure its angle, measure its magnitude, and that would be just fine. Right? And that would be a way to do it. I would suggest let's maybe do something else here, right? So now we'll do something kind of like that. There's a variety of ways we could approach this problem. Now let's assume it's early in a statics course and we don't have a ton of tools yet at our disposal. But I have talked to you about using the triangle and the parallelogram methods. So if I use maybe the parallelogram method, and here we're saying, well, I've got something, we'll say roughly 100 newtons long, whatever that means. You could measure it if you like, but I think we can just roughly kind of draw it in. 100 newtons at 15 degrees. And then I've got 10 degrees from vertical, another force a little bit longer, 150 newtons up here. And again, that is 10 degrees from vertical. Now, Steve, you really haven't done anything. Well, yeah, I get that. Drawing a free body diagram or a simplified diagram becomes so much more important later on in the course. It's going to seem like a silly, redundant step right now, and then you're going to get into problems where you can't do them without drawing a free body diagram, and you're going to appreciate being in the habit of taking this diagram and just drawing a simple diagram where we pretend that hook is just a point, and we apply two forces to that point, and we want to find the resultant. So from the tail of these two vectors, to add them together, I'm going to draw my parallelogram here, and we're going to say I'm going to find whatever this resultant is out here. Okay. Now, there's all kinds of ways you can solve this one. Here's a way you can solve this one. Okay. So here's what I know. If I draw just the parallelogram over here, and it's not perfect, it doesn't have to be perfect, but if I just draw this parallelogram over here, okay, what do I know? Well, I know that this is 15 here and this is 10 there. So that means that this is the difference from here to here, from the y to the x-axis, is 90 degrees. Well, this is 10 and this is 15, so that means the remainder inside, that's 65 degrees between those two vectors. Well, if that's 65 and this is a parallelogram, this also has to be 65 up here. And if this is 65 and this is 65, and it's okay if you can't do this math in your head, you can do it in your calculator. These are 130. Well, this whole thing has to add up. Remember, basic geometry says this whole thing has to add up to 360 degrees around this parallelogram. If these two add up to be 130 degrees, that means, well, let's just draw it out, right? You've got 360 degrees minus 2 times 65 degrees is equal to, what is that, 230 degrees? I think that's right. Calculator. So here's where you have your calculator out and you follow along with me, because otherwise you're going to get bored watching me do it. Yeah, 230. Okay. 230 degrees. And then, so these are each half of that. So if I divide that 230 by 2, 115. So each of these are 115. So this parallelogram where this side is 150, this side is 100, and it's at these angles. Okay. Now, Steve, what the heck are you doing? Well, let me show you. So this is what I know then. I've got this triangle. So if I use triangular method now, I've got at 15 degrees from horizontal, I've got 100 newtons, and then 10 degrees from vertical, I've got 150 newtons. This is 100 newtons. This is 150 newtons. And I've got this resultant coming across here, R. And I know this angle right here is 115 degrees. I should draw that bigger. I'm going to pause and draw that bigger. Okay. Magic of movies here. So, a little bigger drawing now. L2, page 5 of something. What are we going to do with this? Well, I need to know this length R. I don't know this angle here, right? Maybe it's half of 65 based on this drawing up here. It probably is. But we don't know that for sure unless you remember some geometry rules that tells you that. But this is what I do know. I do know this is 115 degrees. We found that earlier. This is 115 degrees. I mentioned earlier that for any triangle, this one is not a right triangle, but that's okay because for any triangle, you have the law of sines. Tells you that I could take, well, the law of sines says that A over sine alpha plus B over sine beta equal to c over sine gamma for any triangle. And then there's also law of cosines, which says that c is equal to the square root of a squared plus b squared minus 2ab cosine of the angle opposite of c, saying that's gamma. Here's what I know. If I call this 100 newtons A and the 150 newtons B, gamma is this 115 degrees. C is my only unknown. That's my result. So this works for any triangle. So what I can do is I can say, well, that means R, the length of R, the magnitude of R, is equal to the square root of 100 newtons squared plus 150 newtons squared minus 2 times 100 newtons times 150 newtons times the cosine of 115 degrees. A few things to mention here. If you're just watching me and you're not taking notes, what are you doing? Are you still awake? You still there? Seriously, you should be taking notes. You should have a calculator. Even a calculator app on your phone's fine. You'll need a regular calculator to take exams, but here your phone's fine. You saw I just had a simple app on my phone. Here's where you pause the video, you calculate these, and you figure out what this is, and then then you're gonna unpause it. I'm gonna show you what the answer is. So pause here, run these numbers, and come back. Okay, you got an answer? Sometimes I'll run these numbers with you, but here I'm trying to get quite a bit into one video. So this is, your resultant is 212.6 newtons. That's what I have written down here. Now, how do I find the angle, right? Because what do I want to know? Well, I want to know theta right there. I want to know this angle. How do I find that? Well, remember the law of sines. Law of sines, I can find this angle. We'll say this is going to be beta. We'll say beta. I can find this beta angle because it's opposite of this 150. Beta, opposite 150. So what I can do is I can say, well, if I take 150 newtons divided by the sine of beta, that's going to equal what I've just found, this R, that's 212.6 newtons, and it's opposite of 115 degree angle, so I need the sine of that 115 degree angle. By the way, I said earlier 2 things. I mentioned 1, be ready, always be taking notes and have your calculator ready. 2, make sure your calculator is in degrees. If you're taking a math class at the same time, it's probably in radians, right? So make sure you know how to switch to degrees to calculate these things. Anyway, sine of 115 radians is going to be different than sine of 115 degrees. We need to find beta. So beta is, you're going to take the inverse sine of this 212.6 newtons divided by 150 newtons times, let's see, did I do that right? Pausing. Okay. Only skip as many steps as you're comfortable skipping. And feel free to always write out algebra. I'll make a mistake. That's okay. The inverse sine of 150 newtons divided by this 212.6 newtons, also times the sine of the 115 degrees. So, if you run through these, I'm getting that is 39.8 degrees. Now, that is not theta. by the way, remember back at our diagram up here, theta is this 15 degrees plus that beta that I've just measured. So my resultant vector is, in fact, I'm a little longer than 15 minutes here, but that's okay. My resultant vector is going to be 212.6 newtons, and the angle is going to be 54.8 degrees. Steve, why 54.8 degrees? Well, remember this beta here is 39.8. We calculated it, but I'm measuring theta counterclockwise from positive x. We're 15 degrees up to this 100 Newton force, and then that 100 Newton force is adjacent to this beta angle of 39.8. So from here to here, the entire theta is this 39.8 plus the 15, that's 54.8 degrees. Pause here and see if you can find what r is in x and y components. All right, you got them? In x and y components, it is 122.5 newtons in the I plus 173.7 newtons in the J. How do we know that? Well, R is also going to be the magnitude of R times the cosine of theta in the I direction plus R times the sine of theta in the J direction. How do I know that? Because R is here, theta is there, this is Rx and Ry, which is going to be R cosine theta and R sine theta. Alright, this video is longer than I like them to be, but that's okay. We'll pick up the next video.